Yeah, hello and welcome to the latest installment of the UK and I webinar series. As you can see, I'm not Carl Babington, who normally introduces these sessions. My name is Richard Jones. I'm a specialist solutions architect, and I'm joined by Dave Lever, who is one of our core solutions architects. Today, Dave is going to be talking to you about Kubernetes on VCF and how to accelerate app delivery with VKS, which is VMware Kubernetes Service and also VM Service. If you have any questions, please post them in the Q&A and not in the chat. And without any further ado, I will hand over to Dave to introduce himself, and I will speak to you at the end of the webinar. Thank you.
Thanks, Richard. Yeah, hi everyone. And as Richard mentioned, today I'm going to talk about Kubernetes on VCF. This is very much an introduction to the service. If you're not familiar with what we're doing in terms of Kubernetes on VCF, then we're going to start from the ground up. An introduction from me, say I'm a VCF solutions architect in the corporate and UKI team. So I've been in the industry 20 plus years as an engineer, consultant, architect, or combination thereof, and have a keen interest in modern apps and cloud native. There's some technical demos, which we'll get into as we go through the demonstration. I record those on this hands-on lab, so no doubt you're familiar with hands-on labs. It's free to sign up if you aren't, and this is the lab reference, so you can go to that afterwards and have a go yourself. Hugo is kindly on the Q&A today. He's going to drop some links in, and this will be one of them, along with some other bits and pieces as we go through. So let's start off by talking about why we want Kubernetes on VCF to start with, or why would we consider running it there. Well, if we look at the Cloud Native Survey, which you may be familiar with, it's run annually by the CNCF, and essentially what they do is they survey their members to try and understand where they are in terms of their cloud native journey, in terms of the adoption of things like containerization and orchestrators like Kubernetes. And what we see, unsurprisingly, is that every year those numbers in terms of adoption just keep on increasing, and that actually these workloads now that are 10 plus years old in terms of the likes of Kubernetes are mainstream, and having a platform that can run these successfully alongside traditional applications is absolutely key. And VMware, which is now obviously VMware under Broadcom, we've been contributing to the CNCF community for a long time. We're in the top 5, so we're right up there with the likes of Red Hat and Google and Microsoft and such like, in terms of projects we contribute, which are ones that we've originally created, as well as supporting other projects that we obviously make use of within our solutions. And that's an ongoing commitment to keep doing that. But all the talk of how wide the adoption of cloud native is, it's not without its challenges. And we do see a lot of challenges for customers, especially around infrastructure complexity and silos. If you're managing multiple public clouds, legacy infrastructure, trying to deploy a cloud native approach when you need that consistent operation model to actually make sure you're getting these workloads out as quickly as needed, there's a lot of challenges there. You start thinking about then how you need to secure these cloud native workloads, distributed systems and the type of open source elements that need to go into them. That's a big consideration. There's a big consideration around tools. You've got multiple teams involved, you've got multiple tools, potential overlap and overspend. You've got to have a lot of consideration around that, as well as how these things interact with your existing traditional applications, which might be virtual machines and might be even the likes of mainframes, for example. So all these things are all still in play. Now, when we start looking at this from a VMware perspective, we're always focusing on 2 personas primarily. One is admins, so that traditional VI admin that is used to deploying VMware resources and infrastructure to users, managing them from an operational perspective in terms of the governance and so on and so forth. We'll also consider it of then the consumers, right? So the platform teams that want to use that consistent set of tools to access these environments to start building applications and services in a frictionless way without getting caught up in all of the operational elements. And the way we approach this from VCF is we break this down and we start with that virtual infrastructure, which is obviously something that we know a lot about in terms of VCF, abstracting that value out of the underlying compute, networking, and storage as part of that software-defined data center layer, so that consistent platform. We then enable the supervisor. This is really the star of the show. This is ultimately provides you with that control plane that allows you then to enable Kubernetes services, virtual machines, and start orchestrating those infrastructure services, etc. And we can extend that control plane with additional services that support those Kubernetes deployments and also add in other potential infrastructure as a service and platform as a service options like database as a service, for example. And from that VI admin perspective, we have the management and governance layers, again, to manage the resources and the infrastructure in those environments. But we also have that view from the choice of interfaces, that consistent consumption layer for our consumers in terms of how they then consume this environment. Now, if we touch on consumption interfaces in a second, it sort of sets the scene for what we're going to talk about today. And so consumers, when you want to actually get up and running, deploying the supervisor and then ultimately deploying Kubernetes workloads, you can do this just at a vSphere level on a vSphere cluster. But obviously, if you're looking at that private cloud approach, talking about self-service and multi-tenancy, then ultimately we look at VCF automation as that way of doing this at scale across all of your vSphere clusters. Now, as I mentioned at the start, this is an introduction to the service. We're going to do a lot of this on that right-hand side, which aligns with that lab that I shared with you. But ultimately, we're going to do this in vSphere today. So the first thing we're going to focus on is that critical component, that supervisor element, right? It's that control plane. Now, the control plane ultimately is a Kubernetes control plane cluster. And the benefit of that is it's Kubernetes, but it's got all of our VMware custom resources integrated into it. So then it provides us with this declarative API for then consuming our vSphere infrastructure. But why is a declarative API something that we care about? Well, again, if we take that consumer point of view and we look at what this looks like for them when they access the public cloud, they have to obviously, again, that common consumption interface, and they're accessing a catalog of services which they consume in a self-service way to start building applications and services. Now, from a private cloud perspective, when we look at also that view from the admin perspective, that cloud providers you ultimately are these days, then we want to give our consumers that same experience in terms of the interfaces they can use to access it and the catalog of service and the self-service approach. But we want to do it with the guardrails ultimately that we can provide in terms of putting the policies and the resource allocation, etc., in terms of what they can actually have access to. And that's ultimately what we're doing when we deploy the supervisor, is we're providing this control plane through the supervisor that allows our consumers to start getting up and running day one on deploying conformant Kubernetes clusters with VKS, deploying virtual machines, coordinating the infrastructure services, and as I say, as that control plane where we can add in then additional services to support those cloud native environments. But we do that with the governance wraparound so that our admin teams are able to control and manage those resources. So if we take this right back to basics, I'm a VI admin, I've got a vSphere cluster here, I've got vCenter and some virtual machines deployed. I enable that supervisor control plane. And as I mentioned before, this deploys as a Kubernetes 3-node control plane. You have the option of a single control plane now in VCF 9, but for the purposes of typically in an enterprise environment, we'll deploy it as for high availability with 3 control plane nodes. And it ultimately enables 3 things for us. One is that declarative API we've just talked about in terms of how we can then manage and deploy those resources. The second, it allows us to actually break down the resources in our vSphere environment using what we call vSphere namespaces. So if you're familiar with the namespace logic within Kubernetes, the way of isolating your resources, we combine that with vSphere resource pool logic to create these vSphere namespaces. So we can then dictate the permissions as to who can access this namespace. We specify the VM class, so the t-shirt sizes of VMs essentially that can be deployed in that environment, the OS images, the storage policies, and we're setting the basis of that whole multi-tenanted type self-service approach, but at just the vSphere level at this point. The third thing it does is it enables our ESXi hosts as Kubernetes worker nodes. Okay, so now we can actually deploy Kubernetes pods directly on vSphere, what we call vSphere pods. Why would you want to do that? Well, if you look at the screen there, you've got the Harbor image registry we're deploying here, which is what we'd use as an image registry service for the Kubernetes deployments. It's deployed as a containerized service. And what we do when we deploy this vSphere pod is all the lifecycle management, etc., of that Harbor service that we've deployed is managed within vSphere. So we're not putting the burden of having to manage an upstream compliant Kubernetes cluster on the VI admin or the consumer. We can just manage that as part of our normal lifecycle management processes in vSphere and ultimately VCF. Now, with that in place, our consumer, again, with that common consumption interface, can log in. They can then access the vSphere namespaces that they have access to, and they can start deploying conformant Kubernetes clusters with VKS. They can start deploying virtual machines with the VM service, or they can deploy a combination of two all in the same namespace. Okay, so whatever's needed to get that deployment up and running. So now we're going to do a demo. It's pre-recorded, but we're going to do this demonstration as, again, we're looking at this from the admin perspective. So I'm a VI admin, logging in to my vSphere environment. I'm going to enable the supervisor service. So we're going to go in, select supervisor management. Now, we have the option here, as you will do in the lab, to just fill this information in from scratch as you go through the wizard, deploy the supervisor. If you've deployed one before, you can export the config, which is what I'm doing here. I've got a config I've pre-built already, and that will preload the settings for me. So that just streamlines how we can deploy supervisors at scale. Then once that's imported, then I've got the option of what networking I'm going to apply to my supervisor. So I have the option of VCF networkings with VPC. Again, check out our previous UKI webinars where we talk about the benefits of network NSX and the VPCs. We can also use VDS networking, where we would then require a load balancer, and our options RV, HA proxy, or today we now include as well an integrated load balancer called the foundation load balancer, if you choose to use that networking option. But as for the lab guide, we're going to use NSX, we can have NSX Classic, so our T0, T1s, segments, etc. Then we're going to specify our cluster deployment. We're going to deploy this in a single cluster, but we have the option of highly available clusters with vSphere zones, and we'll cover that a bit more later on. We're going to deploy those 3 supervisor control plane nodes by enabling that control plane HA. We could deploy a single node if we had edge requirements or just wanted to get this up and running quickly. We specify our storage policies. These are vSphere storage policies that we've already predefined. So again, we just select those in accordance with the storage required within our environment. Specify the management networking for managing the supervisor post-deployment. And then we specify the workload networking. So this is what's going to apply to your namespace workloads that you're going to deploy in here afterwards. Once that's done, you set the control plane size. That'll be dictated by the number of pods you want to deploy in the environment. And then there's the checkbox there to actually export that configuration. And then once we've got past the summary, we click finish, and that's going to go off and start deploying our supervisor. And we'll see shortly that's going to go through to this section here, and that starts working away. So now we'll come back to that in a second, because we're going to first talk about namespaces, because once we've got our supervisor deployed, we're then going to, as I mentioned before, carve up these resources with our namespaces, which we might be doing based on application. We might do it based on whether it's production, development, testing, so on and so forth, just a way of isolating those resources. So again, in this next demo, I am a VI admin, or coming in here, and I'm actually got my supervisor now successfully deployed. And you see I've got the green ticks. That's all healthy and ready to go. I'm then going to basically start deploying my namespaces, which you see is this tab in the top left-hand corner. So we're just going to click namespaces, and then ultimately new namespace. We select the supervisor, which is obviously the one we've just deployed, and we'll give it a name. And then ultimately, if we wanted to change any of the network settings over and above what we specified at the supervisor level, then we have the option of doing that here. And then we click next. We've only got the single zone deployed, and then we click finish. Once that's deployed, and this is real time, so it happens pretty quickly, we get this namespace out in the open, and we can start configuring settings as that VI admin. So we can set the permissions now as to you can access this namespace. Again, specify your users and groups that you're going to assign, that are going to have access here. Then we're going to specify the VM class. So this is that VM t-shirt sizing we talked about. So again, we can create custom VM classes. We're just going to enable the 16 default VM classes that we've got available to us in the catalog already. Again, those could be GPU enabled if you had a requirement for that, which is what we do ultimately in our Power AI solution. Then we select the OS image that we want to be available for our VM service. We're just going to select this one that we loaded into a content library earlier. Again, you do this in the lab, and then we'll also specify a storage policy. Again, this is a vSphere storage policy we can assign to our namespace here. We've also again got the option, once we've got that configured, to set resource limits. Again, not very much like you'd see in that vSphere resource pool. And then with that configured, what we can also do is, if you see in this top right hand corner, we've got a resources tab. Now, what we've done in this particular environment is we've enabled the user interface option locally within vSphere, so that when our consumers log in, they've got this catalog type view so that they can get up and running with the services using the user interface. So you see I've got the core services out of the box available to me in terms of deploying Kubernetes clusters of virtual machines. Now, this isn't enabled by default. You have to enable this as an add-on service to the supervisor. It's called the local consumption interface. So in order to enable that, you need to go into the supervisor itself. So we're just going to go back in to the supervisor. We're going to add on a supervisor service, and that supervisor service requires a configuration file, which we'll see in a second. So you see when we add that service, see we've got the local consumption interface that provides the UI. When we want to add the new service, we need the config files, which are now centrally located in the Broadcom support portal. So you just need to search for the supervisor service. You'll then get access to the catalog of supervisor services you can download and start adding in from there. And there's that local consumption interface. Okay, so now we've got supervisor deployed and we've carved out our resource in the namespace. We can now start deploying our first core service, which is VKS, okay? Which is ultimately maybe familiar to some of you as the Tanzu Kubernetes Grid service. We changed the name of it towards the end of, I think, 5.2, which is vSphere 8 Update 3. I can sort of feel the universal eye roll as I said that we changed the name of a service again, but hopefully it's not changing again anytime soon. Now, it's worth calling out at this point the benefits of deploying an integrated service like VKS, because it's deploying those conformant Kubernetes clusters. And if you're doing this with third-party solutions, there are some comparisons to be made. So if I was deploying a third-party Kubernetes solution virtualized on vSphere, the first sort of challenge I get is that every time I deploy a Kubernetes cluster, it ultimately has to deploy the vendor has to install all of their custom resource logic into that Kubernetes deployment, which means it takes longer to install as it has to add all its operators for storage and networking and so on and so forth. And also it's a larger footprint. Because we do all that at the supervisor level, what we're deploying in terms of VKS is much more lightweight. There's only a light amount of custom resource integration in that VKS cluster. It's largely just Kubernetes. So we can be much more agile and quicker about how we deploy those Kubernetes clusters with a much smaller footprint. The guidance typically then from third parties is that you don't build lots of Kubernetes clusters. You just build one large Kubernetes cluster and carve it up with namespaces. Now, the challenge with that is, you tend to get larger and larger clusters, which get harder and harder to manage. They're obviously more challenging when it comes to lifecycle management and availability. You've got to consider issues around noisy neighbors. If you've got regulated applications where you want that strict separation, then obviously in a separate VKS cluster, you don't have that option when it's a third-party solution. Whereas in VKS, again, these are isolated clusters we could spin up right-sized for your workloads. You're not ending up with these large pet-type clusters that you get when you're doing this from a third-party solution. So now this next demo, I'm looking at this from the perspective of the consumer, because now I've been given access to the namespace and I'm actually going to deploy my Kubernetes cluster. Now, the observant among you might have noticed it says Tanzu Kubernetes Grid, so I'm no longer in vSphere 9. Just in the interest of time, because this lab's got the necessary edits so you can see the process end to end. I'm doing this on the pre-configured 8 lab, but if you're doing the lab guides, then you get to do this, and you'll see the slight differences as it is doing this in 9. But again, I've got my resources tab in my namespace, and I'm going to deploy my Kubernetes cluster. And again, I'm doing this through the user interface in this particular occasion. So again, I'm going to go through and I'm going to give it a name. I can see I've got options now in terms of the Kubernetes version I might want to use. Change the name, network settings or storage settings for my cluster. I specify the number of control plane nodes. I can specify my VM class. based on one of the 16 that I passed through earlier, based on my storage policy. I also set the same settings on my worker nodes in this environment. So again, I have the VM class available to me. I have the storage class options, the OS image I want to use on my worker nodes. And what you'll notice on this right-hand side is that the YAML manifest is building itself out automatically for this configuration. So I have the option then to download this, and if I wanted to manage that to some type of continuous delivery operation, essentially through GitOps, then I could do that by downloading that file and moving it to my Git repository of choice. Now, and we've also got Argo CD as well, integration into the supervisor that allows us to do that, I should mention. Now, once this starts to deploy, and we'll just give it a second, we go into the inventory, and that's automatically now building out those control plane nodes and worker nodes. I'm not having to pre-build any VMs. I'm not having to make sure anything's automated to build those deployments in the first instance. They literally automatically deploy, and that's the benefit of that integrated service with VKS. Now, again, just to double check, that's all deployed successfully. I look at it from that Kubernetes perspective. I log into my declarative API on the supervisor, I select the context of my namespace, I run get nodes, and I can see now that that's that same view as the inventory, and it deployed that cluster in about just under 7 minutes. I look at this from the perspective then, if I'm just doing this through the CLI. So I've got my YAML file. It's the same spec, 3 control plane nodes and a worker node. And all I'm going to do now as the consumer is just run a kubectl apply. And automatically then you see it starting to build out my worker nodes and control plane nodes. Now again, if I'm a platform, working in a platform team, I'm probably used to using kubectl apply for things like deploying my applications. Now I'm just doing this at the infrastructure level. So I've got common syntax I'm already used to using. I haven't got to learn new tools. It's just Kubernetes, which is something I already know. And again, we just double check that that's deployed successfully, do a get nodes, and we could see that took circa 6 minutes to deploy. One thing to mention that came in towards the end of 5.2 and 8 update 3, if we're talking about vSphere, is the fact we disaggregated the Kubernetes service from the supervisor. Now, historically, the challenge was that vSphere, the supervisor, and the Kubernetes service were all tied together in terms of their lifecycle management, which meant we weren't always the quickest in terms of getting our Kubernetes releases out versus the competition. We resolved that by disaggregating that Kubernetes service from the supervisor. So now we can upgrade those VKS versions in a much more in line with expectations, and we're typically about 8 weeks, within about 8 weeks of the actual upstream Kubernetes version. We've also disaggregated the supervisor now as well. So again, this is a fast-moving space. There's always technologies, etc. We want to add into that control plane layer. And so now that with those disaggregated, it means that they're independent, and we can move a lot quicker in terms of getting those services out to market. And actually, as part of the 9.01 maintenance release for VCF, the supervisor had the Argo CD support added to it. So that's an example of how we can independently add those updates. Now I'm going to talk about VM service. So this is deploying virtual machines using that Kubernetes declarative API we talked about with the supervisor. And these are full-blown virtual machines. They're not virtual machines wrapped in a pod, adding any of that sort of Kubernetes complexity to them. They are full-blown virtual machines subject to HA and BRS and all that good stuff. But the benefit is that we're ultimately able to allow our consumers to deploy virtual machines in that same declarative way as they would do their Kubernetes clusters as part of their deployments, where they still need those persistent services, so on and so forth. But we can do it in this desired state way. So again, we're fixing the configuration and enforcing what gets deployed out in the environment. So again, I'm going to do this next demonstration. I am the consumer, and again, I'm logging in to my environment as the consumer. I've been given permissions to that namespace. You can see I'm in my namespace. I've got my catalog of services, and I'm going to deploy my virtual machine. So I go to create a VM, and again, I just give it a name. I'm going to select my OS image that I uploaded earlier that I made available on the namespace. I'm then going to specify my VM class, and then I can specify my storage. Now, as it's a virtual machine, I want to add persistent storage to it. And so what I'm able to do, rather than, to make it nice and simple, I create this persistent volume, but what I have to do is attach the volume and specify the storage policy and put in the capacity, and that is automatically going to go off and build that persistent volume claim manifest object for me. Again, I want persistent access to the virtual machine. I can create a load balancer. So again, by just filling in this dialog box, I'm able to specify the services I want to be available to that load balancer. It's automatically going to go off and build me a load balancer on that virtual machine. Now, in terms of once that virtual machine is deployed, we obviously want to do an amount of configuration to it in terms of setting up the basic settings, downloading the necessary packages, etc. So we have options here where we can add in our scripting logic with cloud in it or sysprep, depending on our OS. And again, that's going to do all of the first boot configuration for us once we've deployed our virtual machine. And again, we have the same logic. We've got all those manifest files that make up that deployment on the right-hand side. And again, if we wanted to manage this centrally through GitOps driven continuous delivery, then again, we can do that just by downloading those YAML specs as needed. Once we deploy the virtual machine, give it a few seconds and it will we'll speed it along and it will basically finish the deployment. And then what we can do is when we go back into that namespace, we can then see the objects that have been deployed. So we'll see our virtual machine, but we'll see the persistent volume that was created. We'll see the networking objects as well. So you can imagine you can pre-create some of these items beforehand if you before you actually build the VMs if you wanted to. So we go into our load balancer has been created and we can take the external IP of that load balancer and SSH into our server, and that's going to give us the Ubuntu splash page that we successfully logged in. Now, we talked about extending the functionality of that supervisor control plane. One of the things, because ultimately Kubernetes itself is just the orchestrator, there's a lot of other elements that you need for successful cloud native adoption, tools like service meshes, logging, ingress controllers, monitoring tools, image repositories, so on and so forth. So we provide a whole catalog of services available to you so you can actually deploy those in your environment, and we support those as part of that infrastructure. So we've got services you can plug into the supervisor. So we've obviously talked through some of these, the image registry, we have Valero for backup. We mentioned obviously the GitOps integration with Argo. We're always reviewing and adding services into this catalog. We've also then got packages for your VKS clusters specifically. So again, we have Carvel packages that include the necessary tooling to successfully deploy Kubernetes. And then obviously we're talking a bit further back around the fact that versus third-party Kubernetes deployments, that we don't just have one large cluster, it's right-sizing those VKS clusters based on your workload requirements, which ultimately might mean you have more VKS clusters. To manage all of those centrally, we introduced the VKS Cluster Manager as part of VCF automation, which then allows you to consistently manage the lifecycle and policies, etc., that assigned to your VKS clusters at scale. And again, that's available to you today if you've got VCF 9.1. 9.0.1, I should say. So that was a couple of weeks back we released that. Just want to talk about then some additional parts from an infrastructure perspective in terms of availability. So we have support for vSAN stretch clusters. So again, it's more of an infrastructure-friendly way of managing availability of your Kubernetes deployments. It's a reference architecture, essentially dictating how your worker nodes and control plane nodes should be in your environment, and the DRS rules required to manage that, as well as the impact of the supervisor control plane moving between sites. So we have that for that infrastructure level view, but we also then have this more cloud native friendly option as well, which is what we call vSphere zones. So again, these are essentially each zone aligns to a cluster. So you deploy your supervisor service across those three clusters. It's much more in line with the underlying Kubernetes architecture and ensures availability in the event that you lose one of those clusters. So again, we've talked quite a bit around this section here around the consumer options around and doing this at the vSphere level. And obviously, really when we start talking about private cloud and doing this at scale across multiple environments, we want to be doing this in VCF automation. And so what I want to do is just spend a few moments just looking at what this looks like when we start doing this in VCF automation. And you can see that the transition really isn't as scary as you might think in terms of actually doing this across multiple environments. So again, if we think back to what we had at the start, with that vSphere cluster, with the supervisor control plane deployed, we might have then another set of clusters and the HA version of a supervisor across those using that vSphere zones. We then break down our resources into regions. So we just define our region boundaries. And then we'll specify our organizations. These are our tenants, essentially, that we would deploy and assign them to the relevant resources that they need access to in those regions. And then we create our projects and ultimately the namespaces, so our pools of resource within those projects. And these projects are governance boundaries where we can assign our organization users to based on what they want to basically deploy in those environments. And again, they have that common consumption there within VCF to actually then access these environments and again start deploying VKS clusters of virtual machines. So we're just adding in those extra elements for the multi-tenancy and doing this at scale, like you would expect to see in a cloud environment. So I've got one more demo. This is based on, if you obviously go on our YouTube channel, we've got a VMware Cloud Foundation channel on YouTube, which these recordings are on, and there's a number of other resources. There's a 4-part series we did on essentially deploying infrastructure as a service by VCF automation. And it's just about 30 minutes long, but it talks you through the perspective of the provider in terms of building out that initial infrastructure with VCF automation, and then looking at it from the organization perspective, then the consumer perspective, and then the operations point of view. And this quick demo I'm going to show you is a small part of that series. So it's well worth watching that if you get an opportunity, just to get those different viewpoints, how this builds out. So you've got a supervisor, we've got a region defined, we've got an organization. It's actually 2 organizations, but we're only working on the sales organization in this instance. Then I'll tell you what they create as part of that process. As part of that demonstration is this customer portal project, which is host the customer portal app. And essentially got 2 namespaces, dev and prod, within there that you can, and they've essentially then deploy these applications, these 3-tier applications in these environments. So what I'm going to do is we're just going to log into this. I'm just going to create this virtual machine here, just so you can see the difference between what this looks like in VCF automation versus vSphere. So again, go into our tenancy, which is in this instance, the Acme Sales organization. I'm going to log in as a Project Advanced user. So as a Project Advanced user, we can build infrastructure as a service, as well as access catalog items. When I log in, I can see I've got my customer portal projects. I've got my dev and pod namespace. I've got some resources I can start consuming here. If I wanted to, I could select either my pod or dev namespace from here, and then I'd go in and start building my services. Again, a familiar looking view to what we saw in that local consumption interface. There's some useful information here around the region I'm in and my project namespace. I can see it's a single zone deployment. I can see my VPC I'm attached to and resource limits. Like I say, this is a view we saw earlier when we deployed this locally in vSphere. Again, we just deployed a virtual machine from there. We're not going to label this as we've seen it once already, but essentially it all looks very similar. We give it a name, specify our image, and again, these are resources we're just allocating from our organization and then into ultimately in our namespace. Again, attach our persistent volume is just as easy, and it creates again those necessary manifest files on the right hand side. So again, if you do want to do this through a GitOps approach, we can, and then essentially again we'll do that first boot configuration. There's a few extra options for guided inputs for Cloud Init if it's not something you're familiar with in version 9. We specify the VPC interface that we're going to use. And like I say, again, I'm going to deploy the virtual machine and there's the YAMLs that we can pull down if needed. So just when we go back to the challenges we talked about before in terms of adopting modern applications and that cloud native approach, in terms of actually what we're doing in VCF and having that unified platform, bringing virtual machines and Kubernetes together, simplifying the process of deploying it, having those different consumption options, providing those workflows to make it simpler. We didn't touch a lot on the security tools. So a lot of this stuff is baked in terms of default security, but we have Kubernetes related tooling like Istio Service Mesh, for example. We've also got the wider portfolio around RV and vDefend that can bolster the security and infrastructure level. And again, we provide that common set of tooling across that, having that consistent platform, and again, gives us those options depending on what type of applications we want to deploy. Let's link to Hands-on Lab. And I hope you found this useful, and I'll hand back to Richard.
Yeah, thanks for that, Dave. Really excellent session. So yeah, many thanks for stepping in and running that session. So just a couple of things, I suppose I just want to highlight really, events or future events that we've got coming up. These are face-to-face events that you can see on the screen. I suppose predominantly focused at UK and Ireland, but I know that obviously we are running similar events, I suppose, globally as well, right? So if you are interested in registering for these events, or any other events for that matter, please reach out to your account representative, right? As I say, there are a number of expert-led workshops that we're running and experience days. So yeah, please reach out if you've got any interest in those. Next slide, please, Dave. Another event that we've got coming up is effectively a VCF 4-day workshop. Again, you'll need to reach out to your account representative to obviously see if you can join or you're eligible to join. But yeah, this is via Zoom, so it's not face-to-face, and it's a 4-day session that's taking basically a deeper dive into obviously all of the component parts of VCF. So yeah, again, if you've got an interest in registering that, looking at that and registering for it, then please again reach out to your account team for that one as well. And last, we've got a global virtual event, a VMUG event, where we've got obviously the guest speaker, which is Paul Turner, who's the Vice President of Products for the VCF division. So that one there you can register for now, and the link is in the resources section. So if you look at the Zoom, go to resources, there's a link for this event, which will take you to the registration page. And there's also a couple of other links. One is to Hands-on Labs, which Dave mentioned earlier on, where you can go and have a play with many different VCF products. If you like, sort of have a play with them, see if you like the feel of them, and then again you can sort of reach out to your account team. Obviously, you need further information on those. And I think the other one is around VMUG, right? So registering for the VM user group. So on that note, I think we're going to end the session. So yeah, just thank you for attending. There will be a short survey that will appear once the event is finished. So if you can take the time, it would be appreciated if you could complete that and fill that in. And it also gives you an opportunity to suggest future sessions and topics that you'd like to see as part of this webinar series. So have a good rest of the day, and thank you and goodbye.